Hello and welcome to the new episode of EVM programming course. Actually, this is the bonus episode that I prepared for you that will hopefully shed some light into how EVM works on even deeper level. So I don't know if you know, but I prepared the article concerning dissecting EVM using go-ethereum a year ago, and it had quite a lot of traction and many people found it useful. And now it's the time to do the same, but in the video manner. And hopefully the people who are more visual learners will benefit from this video. But first, before diving into how EVM is implemented in go-ethereum, I would quickly want to run through some important topics concerning Golang, the language in which go-ethereum is written, because it's rather simple to grasp language, but it has some unique features that are maybe problematic to someone that didn't have any exposure to this language before. And I will use the article that I wrote before for that. So first thing, Go is just kinda object-oriented. It's not as object-oriented as, for example, JavaScript, Python, or even Solidity, where you have contracts that can inherit from other contracts. And you can build levels upon levels of abstraction as in traditional object-oriented program language. So how Golang really achieves something that we can compare to object-oriented programming, because still it's like sometimes it's useful to have this common code logic that is being inherited by others. Golang has two types. One is struct, the same as with Solidity. Struct defines fields that specific structure has, while interface is just collection of method signatures, very similar to Solidity. So we can see here how to achieve object-oriented programming like functionality. We are defining our interface that has two functions, area and perimeter. And then we have three structs. So we have rectangle, we have circle, and you can also see this string notation that circle has geometry, but it does not specify what kind of type it is. In Golang, that means that the circle is something. So that means that circle is geometry. So that means that it has everything what this interface has to offer. So in this notation, you can really think that this is somehow strange, but definition of a class. Here you have functionalities, and here you have all the types. And now, how to implement the specific functions of geometry inside circle. So you normally use the name of the function, and you are also using the type that it returns, as in other languages. But this is how you define, for which interface you want to override it. So in this case, we have C for circle. You can think about this C as, for example, this in other programming languages, or self inside of Python. In this case, you can name it however you want, but this means that this particular instance. So in this case, this C.radius in JavaScript or other languages, it will be this.radius, or it will be in case of Python self.radius. Also, there are no constructors. However, you can create a function that will create new object for you. Concerning this string notation, we will talk about it in some of the next steps. However, what you do, you are initializing rectangle with radius, and that's all what you're doing, and it will return to you a rectangle. Secondly, Go modules are really annoying. If you know Solidity, you for sure know the concept of modules and imports more specifically. So in Solidity, if you want to have some functionality of other contract or library, you are importing it to your contract and then you are using it. In case of Golang, this is called modules, and modules are really annoying because modules don't have to be implemented in single file. So in case of Solidity, if you want to define a smart contract called, for example, payment, so this payment is contained in single file. You cannot have like payment scattered across multiple files and then it being referenced by the name of it, but it happens in Golang. So in Golang, the module can be scattered across multiple files, and the problem is that sometimes you don't know in which specific file the referenced function may be. So I had this issue myself multiple times where I was looking for a specific function with some of the common names, and it LSP didn't work, and I had to use the finder to find by the name, and there was like dozens of different functions that had this name, and this is really problematic. However, like really good IDE can help you with that. For example, Golang, but this is a paid option. I personally use Vim with LSP on it, and it really works really good as well. But I had some problems with VS Code LSP on Linux. So if you do have, please consider using, either Golang or Vim. Yeah, and here's the example what I said. So you may have file in this specific directory and it's package fish, and you can have, the package fish inside different file and some imports. And you may even have the file to be in different directory while still being declared of being the part of the same package. Yeah, and on the flip side, you may have multiple packages. Yeah, and lastly, you may have in this directory 2 different packages, and it will be okay. Next thing, there are no throwing of errors inside of Golang. You may be used to languages, like most of the languages, throwing an error, and this breaks the execution. The same is, for example, for Solidity. However, in Golang, you are not using that. The good practices of Golang are that you are returning optional return value at the end of your function, because in Golang, the same as with Solidity, you can return tuple, which means that you can return more than one type. And Golang uses it to signal whether the error occurred or not. So in this case, for example, a really simple function, if the argument is 42, you are returning new error, which only has, some string message in it. And then how you check whether the error was there, you are defining the return values. similar to Solidity. If you want to get multiple return values, you're doing something like that. And then you are in the same line using another expression. So if the returned value E is not nil, that means that an error was thrown. And in this case, we are handling the error. Otherwise, it is nil. That means the error was not thrown, and we are having our normal execution. Next, go-struct may define metadata, something that is usually done in other languages like Java through or Rust through annotations. However, here, in case of struct, you may define really anything, and this is changed to key value. So then, if you are doing something with JSON in this case, it will marshal this ID field into this name. So you can tell JSON marshaller how to name it. For example, in the case of Golang, you have this database that is called GORM. And then in GORM, you also can define some metadata. For example, that this key, this ID is primary key. For example, and this second is foreign key. If you don't know SQL or SQL, that's not a problem. You don't have to know it in case of Solidity. However, you have just to know from that you may have like multiple different key value representations, the metadata that will be then used by specific libraries or objects in Golang. If you know generics from different languages, which are quite common, to be honest, in TypeScript, again, Java, sorry, I just know Java really well. That's why I'm mentioning it constantly. C#, all, mainstream languages basically have generics, and Golang also has generics, but those were introduced just recently. So normally what you do with generics, you are having like general function that is then compiled based on the usage into multiple functions, but you have to write it only once. Any generic function that may happen to work on different types. So for example, if you want to have separate multiplication functions just for whole numbers and different multiplication for float numbers with decimals, or any other kind of multiplications. In other languages, you just wrote a single function, generic function, that took generic types, and then it was compiled into real types based on the usages. And Go only had this recently, so there are multiple cases when you may look into some Go code and think to yourself, why the hell they didn't use generics, but they wrote the same logic, just changing the types. That's why. That's because Golang only recently had generics introduced. And in software development, there is this concept of what the fucks per minute. So if you're doing code review, the lesser what the fucks person who is reading that has, that means the better the code is. And finally, Golang has this concept of deferred functions. If you see this defer code, that means that it will be executed at the end. So why do you even have that, and do not just write this close file at the end after write? This is actually useful because maybe you have some variable that is only accessible here, and you still want to use it, this value that is under this variable. However, you want to execute the specific action at the end. So this is why defer is used. So every time you see it, you can think about it as being executed at the end after the last instruction in the block. And if you want to see how it works in practice and gain some confidence into reading the Golang code, you can check my supply chain project that I created in Golang and TypeScript, where backend is, of course, in Golang, and it uses logging via Ethereum. So yeah, if you want to see how to connect that and how Go works under the hood, and have some really simple project to understand the language better, you can go ahead and check out my project. Okay, and now to the go-ethereum. We will be using the latest 1.13.14 version. So there is caveat for that, and the biggest change to this version, because a year ago I was describing go-ethereum in one of the previous versions, and it looked differently in the some parts, just because the version that I was talking about still was full client, so it had both consensus and execution part of the client inside. And now we have this split where we have separate consensus client and separate execution client. I will go through the execution client part, and yeah, let's hope that you will learn something from it. Okay, I have go-ethereum. Okay, a trivia here. It's really hard to get a grasp how different JSON RPC methods that I mentioned before are located in go-ethereum. You can see into command util flags, and you have the namespace of it, and then the function names are really used and are coined with the namespace and are added to the API of JSON. And this is really mind-boggling, and we will not go deep into that. If you are interested, this is like a good place to start and see how it is. But the thing is that right now go-ethereum first gets proposed block from the consensus layer, and via this engine API, which is just another JSON method, but this is protected via authorization. So the thing is that execution client should only be able to receive blocks from the consensus client that it believes is valid. So that's why only the credentials are required here. So what happened next is go-ethereum receives this message with transactions, and it starts the processing of the state update. So we can start from here, apply transaction with EVM of state processor. So it takes a single message, a message that is being signed by the network participant, which is a raw message that they send. This is not a transaction yet, but it will be changed soon. Config, which is useful because EVM has to keep all the code of previous EIPs that modified how the chain works at specific blocks. And in the future, there will be new EIPs that will also modify it. So go-ethereum keeps the config here. Gas pool, this is like simple integer that tracks how much gas we have during execution of the transaction. You can see its function: add gas, set gas, and subtract gas for the most part. StateDB, this is interesting. This is the database struct, the underlying database where every changes are being saved. Of course, we have current block number, which is big integer, block hash, the transaction, a gas that is being used, and reference to EVM implementation. And now you can see here that some of these fields have this strange star here. In case of Golang, because this is low-level language, you can have access to the memory. So you can either pass some parameter by value or pass it via reference. So imagine that we have variable a of type int, which initial value is 5, and b, which is also int and also has initial value of 5. And they are passed to two different functions. Function x, which takes a param, and it actually takes a copy of the param. In languages that you can use the underlying memory model, you can either pass something by value or pass something by reference. And normally, by default, if you are not referring to the reference being a star, that means that you are operating on a copy of a value. So the difference between x and y is that y takes reference to the parameter that you pass, and x just takes a value of param. Taking value of param in this case meaning that it copies it before it passes it to the function. So in this case, if we pass our a to function x, and inside this function x the 1 is added, after this function the a itself will still have value 5, because only the parameter that was passed to the function, which is copy of a, will be 6 here, and it outside will still be 5. In case of b, the situation is different because we are passing here the param as a reference. That means that we are sending the actual address of where the parameter is. And one additional thing, in order to refer to the underlying value of the address, we are using this AND operator. So if you are using something as a copy, you add nothing. But then if you are using as reference, you are using this star, and it means that you are really passing the address of the value. So it can be located somewhere different and you are operating on this address. However, then if you want to modify it, you have to use this AND sign to say that I really want to operate now not on the address but on the underlying value. And because we are operating on this b directly on the on the b under the address when it's defined, then after this function the b is also modified. So to summarize, if you are passing something by value, it is being copied and it's being the value is only modified inside of the context that you call. Outside of it, there is no change because you are using like totally new value, a copy of this value. In case of passing by reference, you are really passing address to this location of this b in this case. So if you modify it here, it will be also modified at the original place. That means that after the context that you are calling it into ends, it still will be modified because it modified directly the place where it was put. And this is what we have here. We are passing references, so if you modify it here, it will be also visible in the calling function. So we have block hash, like right now this is empty. Then we have block hash and our transaction used gas and EVM at the end. And we are returning the receipt and error if there was any. Additionally, you may have tracers that is useful for developers of go-ethereum. If something is not working right, or you want to have more insight into how it works, you may define like enable tracer for you, and you will have more detailed logs and you can see how any specific things work. But this is not really very useful from the perspective of understanding how it works. So we will just skip those parts because they are the technicalities usually for people that are working with developing of go-ethereum client. Okay, here we are creating new context. So we have multiple contexts. One of the context is transaction context. What does it mean? It means that we are creating a placeholder for our current transaction. So everything that is happening inside this transaction will be in the context of current transaction. We may have also what we discussed before, a call context, and we will see it also later here, that every call that you have, receives new context and some new variables. In case of transaction context, we have origin, which is message.from, gas price, which is also taken from the message, and blob hashes, because we are in the new go-ethereum version, and EIP 4844, if I remember correctly, which is the dank sharding, is already live. So you can create blobs for your transaction. We will not go into that. It's not really something that you would need to know. Then we are applying message, and this is the core of EVM. We will also go here, but before, let's see how happens here. So we have our message applied. So that means that we executed the message, storages were updated, state was changed, and we have our result and error. In case that error happened, and the result was just whether the transaction was successful or it reverted. And the result that tells some useful stuff. For example, how much gas was used, and we use that to have used gas. Then we check if the result has failed, and we fill in the receipt for the transaction, whether the transaction failed, well, that means that it reverted, or was successful. We are setting the transaction hash into the receipt, gas used. In case this is transaction of type blob, we are additionally adding information about the gas used and gas price. In case that 2 is null, that means that it was a contract creation, because in EVM, if you are sending a transaction to nil value, this is considered as contract creation. If so, you are also adding the contract address to the receipt, all the logs that were emitted, the Bloom filter that I already mentioned before, and you are updating block hash, block number, and transaction index, because in the single block you may have, like, let's say that we have 10 transactions, so we have transaction that was executed first, second, third, and so on. So let's now go into apply message. Super simple. We are just creating a new state transition, and what it does, it just assigns gas pool, EVM, the original message, and state DB that is used by the EVM, and we are calling transition DB. First, we are doing the pre-check, and we have explained here what is being done. So let's go inside. We are checking if the message should skip accounts check. So this is only if maybe you're running your own node and you can set this flag, but normally the skip accounts check is set to false, so it always checks it. So it gets the current nonce of transaction origin, which is message.from, and it verifies it if the nonce from the message is not smaller than the one that is being saved. You are also checking if it's not the opposite, and finally you are checking if this is actually nonce plus 1. So there are multiple checks, but what it really does, it checks if, for example, the blockchain nonce that is being saved for a particular account, let's say, is 5. So it checks if your message has the next nonce, which in this case, in case of 5 plus 1 is 6. And next, this is interesting. We are checking code hash, and we are checking if the code hash is neither empty hash or it has empty code hash, because all code hashes by default, if they are not, nothing is deployed on them, they are not 0, they are catch 256 hash of nil, which is this particular hash. So they check if the message from the person that signed the transaction is not a smart contract. in case of Solidity, it's not really possible unless you find the clash of the address of EOA and contract, which is rather hard to do. And it would really give you nothing, but still they're protecting against that. And here, for example, if this is London, which actually is way above London, we are introducing some additional checks, checking if there is no base fee, gas fee cap is of 0 length, and gas tip cap is of 0 length. If so, it is verifying that, the length of it is not higher than 256 bits. The same for gas tip cap. And if gas fee cap is bigger than gas tip cap, those are, just safeguards against malicious actors. But, why on earth would you want to skip this check? So if you are running your geth locally and you want to test something on your node, like maybe you don't want to pay any fees, you want to, maybe fast something on it and have like the quickest execution, and you don't want, to bother with your fake account having some money on itself or not, so then you can just turn it down. But on the mainnet, this is turned on. Again, we are checking blob hashes, if blob hashes are correct, and then if this is Cancun version and this is checked by block number and current time, we are also checking some additional stuff concerning blobs. And now it's interesting thing, we are buying gas. It's not like the gas is taken from you before, but you have to buy the gas up to the gas limit and the gas price that you send. So you have to have enough funds to cover gas limit times gas price before the execution. Of course, you don't have to use everything, and if you don't use everything, it will be refunded to you afterwards, but before you just have to buy it. So yeah, as I said, you are taking message value and multiply it by gas price, and then you are adding to a balance check to check is gas fee cap is not bigger than user specified. Again, if this is Cancun, you are also accounting for blobs gas price, and then you are verifying if the balance check is not overflowing. So that means if the required gas is not bigger than UN 256, it will be dramatic, because if it would, if you set, for example, so really high gas price and go over UN 256, then it will roll over to like some really small value. So you could really steal probably everything from the chain. So they are checking if this is not overflowing. And then they are getting the user balance and comparing it to what is to be paid for this transaction. Of course, if this is not sufficient, they are throwing an error which says that the execution stopped, the transaction is being reverted, and gas is being subtracted here from the gas pool. Gas remaining for the current transaction is being set to the gas limit at the beginning. The same with initial gas. So initial gas will be constant and gas remaining will be depleted every time that we do any kind of operation. And finally, we are subtracting the balance by the message value of the cost of this transaction. So we are after a pre-check. So we verified initially that it's okay. We bought our gas. Then we are checking all the rules for given time. So normally if this is run on mainnet, it will be most recent rules. But for example, if you are a new client and you are working on some previous block numbers, each time you have different rules. For example, if you are verifying block 1000, 10,000, the rules, of course, you wouldn't have like Cancun, the most recent rules. So you have to have rules according to the current block that you're processing. Then you are calculating the intrinsic gas. So this is the gas that you pay no matter what. So if this is contract creation, you have like 53K of constant gas that you pay for it. If not, you have 21K a constant gas that you are paying. Then you are getting your call data length, and if it's bigger than 0, you are checking how much 0 bytes and non-zero bytes you have, because non-zero bytes cost 16 gas and each 0 byte cost 4 gas. There is this difference. So we are calculating it here, and then you can see, as I said, this is 16 gas, but again, this was introduced by EIP 2028. So if block that we are processing are not in this particular EIP, it will not be active. And all this part is just to verify how much gas you have to pay. Also, important concept, if you have access list, the gas will be taken from you now. What is access list? This is part of one of the EIPs. So you can pre-warm some addresses that you want to use and some storage keys. So for example, that you will use Uniswap v2 address. So you can, with your transaction, send a specific address list, the list of addresses that you will use. And also, if you know what kind of storage variables of this particular contract you will use, you can also add it to access list, and it will be warned for you before the transaction execution. Next, we are checking if the gas remaining is bigger than intrinsic gas. If not, we are reverting it. Next, if this is Shanghai, and this is contract creation, and length of the data is bigger than the max possible contract size, which is 49,000, then it will just revert. So you cannot have code size over the limit. Next, you are preparing state transition, prepare access list, post Berlin, and reset transient storage, because most recently we also have this additional factor, which is transient storage, which is storage that is only there for you for the duration of the transaction. Yep. And finally, if this is contract creation, we are calling different code branch, which is EVM.create, with the data, gas remaining, and the initial value that you send with it. So the message, that value that we sent is passed here. Otherwise, we are setting nonce to the next one. So this is actually making sure that the nonce that user sent, like we verify it before that this is correct. This is one bigger than what we had. And here we are updating it so that before the transaction execution, we already have the new nonce of the account. And again, if this is not contract creation, we are calling this path EVM.call. We will go into both of the paths in a moment, but let's now finish the transaction execution. So here we have the return value, which is byte array. We have contract address that was created, leftover gas, and error. In case of call, this is very similar. So if any error occurred, this is paused here. In return, we have byte array that was returned. This actually for call is not for the highest level call is not really interesting. It is interesting if we have call that calls some contract inside, then the return value will be returned in this array. And next, if this is not London, we are refunding gas with quotient, which is 2. Quotient 2 means that we are dividing the gas to refund by 2. So we are having the max refund for the transaction of 50%. So that was before. However, after EIP 3529, the quotient now is 5. So that means that we can get only 20% of gas to be refunded. So next, again, we check how much tip we paid before. And at the end, after we calculated how much gas refund is for the user, we're adding the balance of the refund again. And we are returning execution result. Okay, so let's maybe go into evm.create